Hello again. So in this is going to be a really short video just to summarise the products that we've accumulated so far during glycolysis, the link reaction and the Krebs cycle. So in this first column I have ATP produced by substrate level phosphorylation. Now during glycolysis, 4 ATP molecules are produced by substrate level phosphorylation, but 2 are used during the phosphorylation of glucose. So we get a net production of two molecules of ATP. During the link reaction, if you remember, none at all. Okay. During the Krebs cycle, with each cycle, if you remember the dinar, far, we get 1 ATP produced by substrate level phosphorylation. Krebs cycle turns twice for each glucose. So we've got 2 ATPs produced by substrate level phosphorylation in the Krebs cycle. So in total, 4 ATPs by substrate level phosphorylation, which is hardly any, considering all of the stages that we've been through. Importantly though, we've produced reduced NAD and reduced FAD. And it's this reduced NAD and reduced FAD which are going to provide high energy electrons and protons, which will enable the mitochondria to produce a lot more ATP by a process called oxidative phosphorylation. So glycolysis produces 2 reduced NADs. Each time triose phosphate is oxidized to pyruvate, 1 oxidized NAD becomes reduced NADP. Sorry, reduced NAD. During the link reaction, we get another 2. So pyruvate is decarboxylated. At the same time, NAD is reduced from reduced NAD, and that happens twice because you start with 2 pyruvates. During the Krebs cycle, with each cycle, dinar, we get 3 reduced NADs. We know that the Krebs cycle goes around twice, so 6 reduced NADs. In total, 10 reduced NADs are formed. Reduced FAD. Well, we know none during glycolysis, none during the link reaction. Dinar, far, so 1 with each cycle. 2 are produced in the Krebs cycle from each glucose molecule that we begin with. So we end up with 2 there. Okay, this is a really useful table when we're trying to add up the total amount of ATP that can be produced at the end of oxidative phosphorylation. So the 10 reduced NAD and the 2 reduced FAD are now passed on to the oxidative phosphorylation at the electron transport chain. Okay, thanks.